So when we talk about the spinal cord reflexes in terms of neurophysiology, there is the muscle spindle reflex, there is the stretch reflex, there is the Golgi tendon reflex, there is the flexor reflex, but there are some other reflexes which are also known as the reflexes of posture and locomotion, and they're also very important and even are present in terms of decerebrate and spinal animals. So in this lecture, we're going to take a look at the reflexes of posture and locomotion, in which we're going to talk about the posture and locomotive reflexes, stepping and walking movements, and mark time galloping and stretch reflexes. So let's start with the positive supportive reaction, and it is a very common phenomena if you observe, and it is very easy to understand as well. So this type of reaction is used to support the body, and it is also known as the magnet reaction. What happens is that whenever, for example, if we pick up an individual, for example, a baby or an animal, and when you try to bring the person, the baby, the animal, towards the ground, and when the feet touch the ground, even though you are picking the animal or the individual up, so the feet receive a stimulus, and that stimulus is sent to the spinal cord, which results in the extension of the joints or the extension of the legs, so that the person or the individual or the baby or the child would actually stand and to support the body. And that is why it is known as the positive supportive reaction, and that is why it is also present in decerebrate animals as well. And it is known as magnet reaction because the locus of pressure at the feet determines the direction of extension, so that there would be an appropriate positive supportive reaction, as you can see in this baby or a child. So when the feet touch the ground, the baby tries to extend his knees automatically, so that he would actually try to support his body. So the stimuli is the pressing of pads, fingers or toes, and they may result in dorsiflexion or plantar flexion or any other appropriate movement and extension of the knees and so on. This would result in afferent information from skin and muscle, which would go to the spinal cord, and the effect would be hand and feet extended to support the body. Limb becomes as solid, rigid pillars to support the body on the base of support, and that is known as a positive supportive reaction. Now, there's another type of reflex which is known as the cord writing reflex. So whenever a spinal animal or a decerebrate animal is laid on its side in a side-lying position, it will make uncoordinated movements involuntarily to try to raise itself to the standing position, and this is known as cord writing reflex, as happens in sometimes in different types of insects. So when you turn them around, they try to straighten themselves up, or they try to raise themselves to the standing position, and that is known as the cord writing reflex. So animal with well-healed transected thoracic cord between levels for forelimb and hindlimb innervation, you would see that the individual or the animal would try to right itself from lying position, and it may even walk using its hind limbs in addition to its forelimbs, even though there is a transection of the spinal cord at the level of thoracic. You can say the upper extremities are being supplied normally, but the connection of the lower extremities has been discontinued with the higher centers of the brain. But even still, the animal or the individual tries to right him or herself and even try to walk, and that is actually observed in an experiment even in opossums. So in opossums, there was a similar transaction of the thoracic cord in the experiment, and walking movement of hind limbs was present even with the transaction of the spinal cord at the thoracic level, and the walking movements of hind limbs were hardly different from those in a normal opossum, except that hind limb walking movements were not synchronized with those of the forelimbs as in a normal opossum. Another type of phenomena is a rhythmal stepping movements of single limb. So this is observed in spinal decerebrate animals, and it happens when the lumbar portion of the spinal cord is separated from the remainder of the spinal cord, and other than that, there's also a longitudinal section or longitudinal transaction is made along the lumbar spinal cord. So this actually blocks the neural connections between the two sides, and what happens is that there is no connection between the two limbs. So there is rhythmal stepping movement even if with the transaction of the spinal cord at the lumbar level, but there is no coordination of the movement of those limbs with each other. So the single limb performs stepping movements independently of the other limb. But in terms of the case where there is no splitting down or longitudinal splitting in the center of the lumbar spinal cord, there is reciprocal stepping of the opposite limb. So if there's a stepping in forward direction in one limb, let's suppose the right limb, there would be an opposite limb ordinarily moving backward, which would be in the case that if the right limb moves forward, the left limb would automatically move backwards, even if there is a transaction at the level of the above the spinal lumbar spinal cord. So this is due to reciprocal innervation between the two limbs in terms of the spinal cord reflex pathway. There's another type of reflex which is known as the mark time reflex. So what happens if there is a well-heeled spinal animal or a decerebrated animal, and that animal is held up from the floor and the legs are allowed to dangle. So the stretch phenomena or the stretch sensation on the limbs occasionally elicits stepping reflexes that involves all four limbs, and the animal starts to behave as if it wants to or if it tries to walk, and you would see that there would be movement of the legs in a way that if the animal is walking, and it is once again a manifestation of reciprocal innervation at the level of spinal cord reflex system or the pathway, and it is occurring entire distance up and down cord between forelimbs and hind limbs. So both forelimbs and hind limbs are being involved, and they are moving to and fro as if there is a movement of walking or gait in those animals. This mark time reflex occurs because there is unequal pressure or stretch to stimulation in different limbs, and that is why they are moving at different times as in a normal walking of the animal. But when these stimulus are actually occurring in such a way that there is equal stretch or pressure stimuli applied to limbs on both sides at the same time, so that animal or that decerebrated animal actually adopts the formation of a galloping reflex as observed in the gait of a horse when it gallops. So both forelimbs move backward in union while the both hind limbs move forward. So this occurs in the galloping stance when there is actually equal stretch or pressure stimuli applied to the both sides of the body at the same time. So as I already mentioned, so there is equal pressure or stretch stimulation in the galloping reflex, whereas there is unequal pressure or stretch stimulation in the mark time reflex. Now, if you take a look at the animals, you would see that whenever they have the feeling or sensation of itch, they scratch it, and they scratch it with their paws or their feet, and they always reach the exact spot where the itch is disturbing them. And that is because of the 2-point discrimination and because of the body position and body sense phenomena. And they then, after reaching that point of irritation or itching, they scratch it by to and fro movement, and most of the time that is involuntary for those animals because that is known as a scratch reflex. So what happens is that there is a stimulus which is irritating them on the skin or dorsal aspect of the skin or the lateral aspect of the skin. So two phenomena come into play. One is the position sense, which is actually a proprioceptive sense, and the animal is able to exactly find the point of irritation or itch with its paw. And then there is second phenomena, which is to and fro scratching movement. That is also involuntary. So the receptor is actually responsible for the detection of this itch or this irritation, which is actually a combination of tactile and pain receptors. And then there is a multisynaptic reciprocal inhibition circuit in terms of the spinal cord reflex phenomena, which results in the removal of the source of the irritant. And how is that source of irritant removed? It is done via the use of position sense to find the exact point of irritation, and via the to and fro scratching movement to remove that source of irritant and itch. And that is what happens in a scratch reflex. So that was all about the postural and movement reflexes at the level of the spinal cord reflexes. I hope you learned something new out of it, and keep on watching sqadia.com for more lectures like this. Thank you very much.